All right, grade sevens, this is your review piece. I'm just going to turn up my mic a little louder than usual for the sake of the video. So if I have a bit of a loud voice, I apologize. But we want to make sure that you can watch this from home in case you're having any struggles. So today we're going to look at adding fractions. This is a quiz that you had earlier this year for adding fractions. And we're going to go over it in the video, and then you have the assigned stuff in the textbook. So this is write an addition equation for each picture. First, I'd like to illustrate this one. We're going to take this as 1/2 plus 5/12. So let's take a look at that. We've got 1/2 plus 5/12. 1, 2, 3, 4, 5/12 and a half. And so we need to find an answer for this. And so if I put this in writing, I now have 1/2 plus 5/12, which is what's being asked for in the quiz. So I'm able to come up with that, but we need to figure out what it equals. Now we know Johnny always does it wrong. Johnny just goes 1 plus 5 and 2 plus 12, and he goes like this. But where did he get 14ths from? Well, he added the bottom. We don't need to add the bottom, and here's why. Let's start over. If I have 1/2 and 5/12, I need to get the denominator the same. But I want to show you, I could fit 12s into here. So if I start stacking up the 12s, and probably some of you have already guessed how many 12s are going to get in here. There's going to be 6. We can see that 6 12s are equal to 1/2. So what we did, if we change this to get to 12, we times 6, and we do the same top and bottom. So that equals 6 over 12 plus 5 over 12. Now we know Johnny would add the bottom. But let's take a look. If I have 6 12s plus 5 12s, what do I have? I have 11 12s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that equals 6 plus 5 is 11, and the 12s stay the same. We know Johnny probably would have added 12 plus 12 to get 24. But 11/24 would be much smaller than that. We do not change the bottom when we are adding. So let's take a look at the next one. The next question in the quiz says 2/3 plus 3/4. Well, let's just do that one right here. I've got 2/3 plus 3/4. What's a common multiple of 3 and 4? Yes, Mr. Jimmy. 12, I agree. Well, let's look at 2/3 and 3/4. Let's see if I can find 2/3. Let's see if 2/3 in yellow. 2/3 plus 3/4. And you're saying that I could turn these into 12s? All right, let's see if I can do that. Let's see. Can I divide 1/3 into 12s? Let's see. Look at that. 4 of them fit perfectly. So if I get 4 there, I'll get 4 here. And if I get, how many are going to fit in a third, do you think? How many 12s fit in a quarter, I mean?
3, yeah.
12 12s in a whole, so a quarter's going to have 3. And now you can probably guess how many 12s we're going to have altogether. Well, there we go. It all fits perfectly. Let's take a look at our numbers and see if we can get there. Okay. So I'm going to turn these into 12s. So to turn a 3 into a 12, I have to go times 4. So I'm going to do that same top and bottom. To get a 4 to go to 12, that's times 3. Now I want to show what this means. So for every third, there are 4 12s. We did times 4. For every quarter, there are 3. So we went times 3. And then look at this. We know that there are 3 or 4 of them in each third, and 3 of them in each quarter. So let's see. Let's rewrite this. 2 times 4 is 8. 3 times 4 is 12. 3 times 3 is 9. 4 times 3 is 12. Now we just add the top. 8 plus 9 is 17 over 12. Wait, is that a proper?
No.
No. Do I have more than one?
Yeah.
I do. In fact, let's take a look at our tiles here. let's see, I've got a 1 piece here. Let's see how it stacks up. There's 1. How many 12s does that cover? 12, 12. So a 1 and 1, 2, 3, 4, 5 12s. Well, sure enough, look here. 17 or 12, that's equal to 1. And there's 12 in there. And 5 12s. 12, 12 is equal to 1. And 5 12s. So there's your answer. Now the second one, it says, sketch fraction strips and a number line for each model. We're just going to do a couple of these. We'll try the first one. It says 2/8 plus 3/8. Okay, so I've got 2/8 plus 3/8. Oh man, this one's really easy, isn't it?
It's kind of hard.
Easy peasy, right?
Yeah.
All right, so let's do a harder one. Let's do 2/3 plus 1/6. Okay, so I'm going to do 2/3. 2/3 plus 1/6. We'll call it a 6 there. Okay. So I need something this can fit into that these can fit into. How big do you think we should go?
As small as possible.
As small as possible? Here, let's go back to our numbers. We'll figure it out. So I've got 2/3 plus 1/6. What's a common multiple that these both go into?
6.
6? Sure. Sure, let's try that. Well, that's a 6 already. 2, 2. Oh, sure, and look at this. If I look at those thirds, 2/6 fit perfectly. So for every third, there's going to be 2/6. So that's a total of 4/6. 1, 2, 3, 4, 6, plus the 1/6. 5, 6, 1, 2, 3, 4, 5. Is that proper?
Yeah.
Is it simplified? Does it look simple enough?
Yep.
All right, cool. We're gonna move on. So I'm gonna do this a little faster. We're gonna do 1/2 and 2/5, and I'll just do it with these. So let's see. I've got a 1/2, and I've got 2/5. Okay, so what's a number that 2 goes into and 5 goes into?
10.
10? Okay, so if I did tenths, I could fit them in there and line it all up? Yeah, let's see. Let's see if tenths line up for a 1/2. Anyone want to predict how many tenths are going to make a 1/2?
5.
You got it. Nice, I got 5, 10. Oh, my magnets are starting to click together. I better be careful, it's going to turn into a comedy routine. Okay, there we go. 2/10 for each 5. There we go. Oh, yeah, these magnets, they are troublesome this morning. I think they were making a plan against us. There we go. So let's do the symbol. I can see how it works out. So I've got 1/2 plus 2/5. But for the 1/2, we did times 5 because it's times 5 to make it 2 to a 10. So go times 5. As we notice, there's 5/10 for every 1/2. I've got 5/10. 5/10 equals the 1/2. 2/5 equals 2 for every 5th. So I've got 4/10. So I've got 1, 2, 3, 4, 5/10 plus 4/10 equals 9/10. There we go. All right. Now, here's the problem. It said do it as a number line. Uh-oh, yeah. I saw a couple faces go, oh man, number lines, man, number lines. Well, we've got 0 and 1. Here's my halfway. How many tenths between here and there?
5.
5. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's see. 1/2. Here's my 1/2. And then there's 2/5. 1, 2. 2/5. And there's my number line. All done.
Done.
All I had to do was break it into tenths, and then I could place them.
Go higher.
All right, last one. Oh, I love this one. kids make a very classic error with this. Okay, it's not quite clear yet. Oh, there it comes. Prince, I love chocolate. Do you remember this one, guys?
Yeah.
Yeah. Prince, I love chocolate, and Princess, I prefer carrot cake. We're eating cheesecake at the Cheesecake Factory. Prince, I love chocolate, ate 2/3 of his piece of cheesecake. And Princess, I prefer carrot cake, ate 1/2 of her piece. They didn't want to waste it, so they packed it up in a box to take back to the palace. How much did they have left to take home altogether? All right, first, let's start. I have 2 pieces of carrot cake right here. We'll just pretend. There's 2 pieces of carrot cake. We'll widen this up so we can see. Well, I'll have to do it sideways so we can see. Let's see, Prince, I love chocolate. He ate 2/3, so let's find those thirds. He ate 2/3 of his. And she ate, how much did she eat? Half? She ate half. She ate only half of her cheesecake. I want to show you what most kids do, and you might catch the error. Take a look here. He ate 2/3. She ate 1/2. Zoom this in so you can see a little better. So first we need to make the denominator the same. We're going to go to 6. So we're going to have 4/6 plus 3/6 equals 7/6. And then usually kids go, there you go. They are going back to the palace with 1 1/6 piece of cheesecake. So wait a minute. I'm not so sure. Let's take a look at these again. We put this together. They ate 1 1/6 pieces of cheesecake, didn't they? Or if we put this, we had said that it was in 6. So let's put this in 6. 1, 2, 3, 4, 5, 6, and 7. So we were right that it was 7/6. But if they ate this much, is that how much they're taking back to the palace?
No.
No. How much are they taking back to the palace?
5.
What's left? 1, 2, 3, 4, 5, 6. How do we do that symbolically? 2 minus 1 1/6 is equal to 2 minus 7/6. Wait, 2, couldn't I say that's like 12/6 minus 7/6? I have 5/6 that I'm taking back to the palace.
So I did.
It's kind of a mean trick, isn't it, that one? I find most kids kind of mess it up at the end. They can add the 2 pieces of cake together, but they usually forget to minus it from the whole. All right, ladies and gentlemen, if you follow along and you do the stuff in the textbook, I think you're going to have some success.